Welcome to PaperBrain. PaperBrain is a platform which helps in simplifying, understanding, and keeping up to date with research papers and scientific literature. It also enables to make research in general a lot easier, more accessible, and quite fun. So here we have a landing page, a minimalistic landing page of our web application. And now I'll click on continue and walk you through the rest of the web app. First of all, we have the search interface, and as the name suggests, this helps us to look up for research papers either by using keyword search or by describing the paper that we are looking for in a natural language. So first of all, I'll demonstrate the keyword search. Either you can type in the exact title of the paper, or let's say the keyword that you want to look for. For instance, I want to look for this paper titled Drag Fusion, and here we have the exact paper that we're looking for. Or optionally, you can type something like information retrieval and get all the papers related to information retrieval. So this was the keyword search. Now I'll move on to the semantic search. And as the name suggests, for semantic search, we have collected around 1 million research papers from publicly available dataset of archive on Kaggle, and I computed the embeddings of the abstract and title of those research paper and stored it in a vector database. And every time, let's say, a user searches a query, for instance, we have this query, what is the best method to fine-tune an LLM? So in this case, I'll click on search, and this is going to retrieve the most relevant results based on the semantic meaning of this paper, this query, rather than just based on the keywords present here. So here we have different papers, and the results you can see are really close to, let's say, what we want to get. And here we have a similarity score, which also is pretty high out of 100. For comparison, let's say you want to search the same query in keyword search, you can see the difference and precedence semantic search has over keyword search. So if I search the same query in keyword search, the papers are not really going to be relevant to what I want, because it's not one keyword here. There are multiple filler materials here, which kind of confuses the keyword search. By the way, for keyword search, we aren't using anything crazy here. It's just simply an archive API call to the publicly available API provided by archive. Now I'm going to demonstrate the chat feature. So let's say we had I'm going to search for the same query, and yeah, let's say we have this paper. I click on view PDF, which is going to render the PDF here in the web app only. And let's say while reading the paper, due to the verbose literature, we are unable to understand few terms. Let's say we're going to look up for what is quantization, and it's going to compute an answer based on this particular research paper. This feature is built using a retrieval augmented generation pipeline. I tinkered around with various retrieval techniques, like building a custom chunking pipeline tailored for research papers. I tried techniques like RAG fusion, hypothetical document embeddings, query expansion, and so on. I also used something out of the box like LangChain, and I found there was a trade-off. If I wanted lower latency, I could use something like LangChain, but if I wanted super high accuracy, I could go for the custom building the RAG pipeline in a custom way. So I guess this was all about the chat and search feature. Now moving on to the next part, we have upload. So the upload feature basically is similar to the search one, except for searching, here we upload research papers. So here we have I've uploaded a research paper quite a while ago, and these are my previous chats. So yeah, that's pretty much it about this one. Now moving on to the ask feature. So the ask feature basically enables us to ask research questions and get a detailed as well as summarized answers with inline citations of the source papers from where it has computed the answer, so the veracity of the provided answer can be assessed. So here, let's say there's a new query, and by the way, here are a few questions that I've previously asked, and let's say I'm going to talk about what the benefits of RAG or fine-tuning. So what's going to do is basically conduct a hybrid search and search for the most relevant papers, and then further re-rank it to make the final answer more suitable. And then a well-prompted model will be used to curate a final answer based on the given papers. So here, as it says, it's offer higher efficiency, better handling, and so on. And here's the detailed answers. And here you can see the inline citations to assess that the model is not really hallucinating. And these are the source papers from where it has computed its answer. Now moving on to the podcast feature. So the idea for the podcast feature actually got it when I was checking out Automake, and then I realized it's super cool to listen to research papers rather than having to read them. And then I iterated over that idea and eventually finalized that podcast version of papers would be the best way to go about it, as I observed a lot of people being fond of listening to podcasts. And it would make more sense, and it would be more engaging than a simple summarized audio version of papers. So here you can see my library where I have created podcasts of some of the papers, and these are the podcasts available for everyone to listen to. I'll give you a quick demo of how one can create a podcast. I'll type for a look for a research paper and arbitrarily select anyone. Let's go with this one. Click on create podcast, and here we can select podcast style. So what style represent is the way in which the speakers in the podcast would be engaging. Would it be in an expert manner, or moderate, or easy, or should the podcast be funny? So I'll just go with funny, or let's say moderate, whichever will suit. And then I can select the voices of the different speaker. So I can just go with, let's say, Emma, Noah, and Ethan for say. And I'll click on create podcast, and this will basically create a podcast task in the backend, and a Redis message broker will handle the background task. And once the task is done, once the podcast is created in the background, it will be rendered here and be seen. So it's gonna take around 6 to 7 minutes. So yeah, that's not feasible for the scope of this video, by the way. So I can basically show you a quick demo of one of these papers, and I'll click on this paper, and this is gonna take us to a new screen. And here it is. So this is the abstract of the paper, the authors, and this is the entire transcript of the podcast. I'll click on play, but I'm not sure if you can listen to the audio, but I'll give a link to this particular podcast so that you can listen to it. And after 5 to 6, 7 minutes, I can show the podcast that I just generated would be available here. As you can see, here's a blueprint, and once the podcast entirely generated, I can see the thumbnail here as well. So I guess that's pretty much about PaperBrain. And yeah, let me know what you think about it. Thank you.